So in this video we're going to find the angle between two given vectors. So it says given that u equals 2, negative 1, 2 and v equals 1, 1, 3, find the angle between u and v. So what we'll do, we'll draw a picture for fun. Here's u, here's v. We're trying to find this guy right here, the angle between the two vectors. Also notice, just as an aside, if two vectors are parallel, then the angle between them is either going to be 180 degrees, or if they're facing in the same direction and you put them toe to toe or initial point to initial point, the angle between them is going to be 0 degrees. Just kind of putting that out there as an FYI. So in the previous video we derived the formula for the angle between two vectors. We found that the cosine of theta is equal to u dot v over the size of u times the size of v. So to find the angle between these two vectors, we just use this definition right here. So we do u dot v. So u is the vector 2, negative 1, 2, and we're dotting it with the vector v, which is 1, 1, 3. And then we need to divide by the size of u times the size of v, and the size of u is just the square root of the sum of the squares of the vector components by previous result. So the size of u is going to be the square root of 2 squared plus negative 1 quantity squared plus 2 squared times the size of v. So the size of v is going to be the square root of the sum of the squares of the vector components. So it's going to be 1 squared plus 1 squared plus 3 squared. And then it's just a matter of going through and simplifying. So the dot product here, we get 2 times 1 plus negative 1 times 1 plus 2 times 3 all over the square root. We get 2 squared is 4 plus negative 1 squared is 1 plus 2 squared is 4 times the square root. We get 1 squared is 1 plus 1 squared is 1 plus 3 squared is 9. And then continue to simplify, so we get 6 and 2 is 8 minus 1 is a 7 all over the square root of 9 times the square root of 11. And if we didn't have a nice square root here, I mean this is a perfect square sitting under here, we could bring these together. So I could make this the square root of a 99. If we have the square root of a positive number times the square root of a positive number, we can bring the two positive numbers under the same radical sign. I don't need to do that in this case because the square root of 9 comes out nicely as 3, so I get 3 root 11. That's in simplified radical form, and this is the cosine of the angle between the two vectors. So if I wanted the angle itself, which in this case it identifies to find the angle, I would take the arc cosine or cosine inverse of both sides. And so this is the angle between the two vectors. And remember, when you have two vectors placed toe to toe, there's really two angles they form. There's this angle and this angle, and what we want to remember is the arc cosine function. The range of the arc cosine function is that it gives us angles between 0 and 180 degrees, or between 0 and pi radians. So anyways, this is done. This is the angle. This is the exact angle between the two. It could be approximated using a calculator. It could be approximated using GeoGebra or whatever tool you're using to approximate things.